Hello, I'm Xavier Lad, software engineer working in Paris for Intel, and in this screencast I will show you how you can use the NDK with Android Studio. Let's start by opening Android Studio. Here we'll create a new Android application. So classic one, let's call it NDK sample, and let's target API 15 minimum. Once it's created, we can go, for example, to our main activity file. So in this class, we can create a new method that we declare as native. So I propose this method will be used to retrieve a string from the C and C++ side using GNI. So let's call it getString from native as native. So now we rebuild the project to generate all the classes. So we'll be able to use Java H. So you can create manually a GNI folder, but let's do it using Java H. So we'll directly have a stub with the proper method definitions inside. So let's call Java H, generate the files inside GNI. Let's use the declare the class path to the Android framework as well as to the generated classes. That will contain all the information Java H need to generate the stub. So we need also to give the full package name with the class name. Let's run it, and now you can see after a refresh that GNI folder has been created. So with inside a stub, so come example NDK sample app main activity, containing all the method definitions. Let's create implementation inside main.c. You can see that here the functions prototype that has been generated by Java H correspond to our getString from native we declared from Java as native. So it's starting with Java and then package name, class name, and method name. So here we're doing the implementation, and we'll call the GNI environment to return a Java string. So inside this Java string, we'll put hello from GNI. Right now there is a small bug with the NDK under Windows when used with Gradle. So we need to create a second C source file empty, because when we compile only with one file, it's failing. So let's now compile our project. We first need to configure the NDK. We can do so in the local.properties file. So exactly like we declare the path to the SDK, we declare the path to the NDK. We can also delete this local properties file and just use environ variable called Android NDK home. Let's fix one small typo here. And now we can build our project again. So now it has been built. You can see inside the build folder or NDK folder, the proper libs have been generated. So you can see the .so files. They have been named libapp.so by default. And we can go inside bird.gradle to change that. So inside the default config block, we can set the NDK configuration and set here module name. Let's call it mylib. Now going back to our main activity, we'll be able to use our newly created lib. So let's load it from a static block using a system.loadLibrary, setting only the library name, mylib. So we can directly see if this is working. We'll call getString from native to change the content of a text view. So let's first give an ID to this text view. So we'll be able to modify it inside the onCreate of the main activity. Let's call it my text view. Now going back to the main activity again, we can retrieve access to this text view using find view by ID like always. So as argument to set text, we can directly call getString from native that will return our string from the native side. GetString from native is still declared as native, as you can see here, and the implementation is inside our main.c file with the proper function prototype, and it should return hello from Geni. So let's launch this. We are launching the application inside an x86 emulator, and it's installing. And here it is with our hello from Geni string that comes directly from the C and C++ side. Now let's go back to our application to go a little bit further and see how we can generate different one APK per CPU architecture. So we can do all this inside the build.gradle file. So let's go to the official Android New Build System website where you can see some tips. So tools.android.com, TechDocs, New Build System tips. And there is one for properly using flavors with ABIs. So let's copy and paste it to our build.gradle file. So this snippet is not only for different APKs for various ABIs, but also for various APIs, API levels. So let's strip the API part. The good thing about this snippet is it will use ABI filter to filter each of the build variants you want, but it will also set up the version code accordingly. So you will always have the higher version code for the x86 version than for the other versions. And that's quite important when you are targeting devices like x86 devices that also support ARM ABI. Before we rebuild our project, let's look at the APK that was generated before. So let's open it like a zip file, and you can see inside the lib folder there is one folder per ABI, and they are all there. So let's sync our Gradle project to see build variants that should have appeared. In order to keep only the ABI we want, we are using the ABI filter property, so inside the NDK block. Now we can sync our Gradle project again, and let's look inside the build variants, and you can see all the ARM, FAT, MIPS, and x86 build variants are available. So let's pick the x86 release one. Now it has been compiled, we can look into the generated APK, so it's called x86 release here. It's a little bit smaller than the former one, and inside the lib folder there is only the x86 folder with the x86 library. You should have noticed before we don't have any android.mk or application.mk file like we used to have when we were using Ant and Eclipse. You can still configure things, but everything should happen inside build.gradle file. So inside your NDK block, you can, for example, set the STL library you want to use using STL property. So you can set STL port static, shared, or GABI++ static, and others. You can also use the LG libs property to set the libraries you're using, like log, OpenGL, ES, and so on. Inside the NDK box, you can also use the cflags property to give flags to the C compiler. And you can even do so inside your flavors, so it's a lot more useful since you can have CPU-dependent cflags. Like for x86, we can set here mtune equal atune, mSSE3, and m floating pointer math to SSE. That's it. Thank you for having listened to me during this screencast.